Good evening student. Today is going on online physics class. I am Pratish Kumar Acharya. I will discuss about electric field intensity due to an electric dipole at any point. Already I have covered electric field intensity along axial line as well as along equatorial line. Along axial line, the magnitude of electric field intensity is given by 1 by 4 pi epsilon 0 to p by rq as well as its direction can be represented along the direction of dipole moment. In equatorial line, the magnitude of electric field intensity is given by 1 by 4 pi epsilon 0 p by rq as well as its direction opposite to that of electric dipole moment. Clear? Now I will discuss about electric field intensity at any point due to an electric dipole. Here it is an electric dipole AB and the direction of dipole moment moving from minus q charge to plus q charge. Let us consider a point P which is situated at any point. That point P, which is a distance r from the center of the dipole O, and it also creates an angle theta to the resultant dipole. And that dipole is resolved into two components along horizontal direction as well as along vertical direction. Along horizontal direction, that dipole moment represented as a p cos theta. Along vertical direction, the dipole moment represented as a p sin theta. The point P, which is acting along the line of the axis of the dipole, that is along horizontal line, we know that the electric field intensity along axial line is given by 1 by 4 pi epsilon 0 to p by rq. Okay, this is the magnitude. So here in that case, the electric field intensity at point P due to horizontal axis or horizontal dipole that can be represented as 1 by 4 pi epsilon 0 to p cos theta by rq. Similarly, the point P, which is the distance r from the center of the dipole which lies along vertical direction. So the electric field intensity at point P, which is situated at an equatorial line of that dipole, we know the magnitude of electric field intensity at an equatorial line E equal to 1 by 4 pi epsilon 0 P by rq, but which is lies in vertical direction, P can be represented as a P sin theta. So 1 by 4 pi epsilon 0 P sin theta by rq. Clear? Let's start my topic with theory. So theory. Here we write that let us consider a dipole AB whose dipole moment P vector, that resultant dipole moment P vector. So this one is the resultant dipole moment P vector resolved into two components. It is along horizontal direction which represents as P cos theta and also along vertical direction. It's represent as p sin theta. Here in that diagram, that resultant p vector can be represented to two components. That two component can be represented as a p cos theta along horizontal direction. That is the direction of dipole moment from minus q to plus q charge, and it denoted as p vector cos theta. And oppositely in vertical direction, it can be represented as j p sin theta, and the direction of dipole moment from minus q to plus q charge in vertical direction. Clear? Now we know the electric field intensity at any point, that point P, which is lies acting along the horizontal direction, so it behaves as an axial line, and that point P, which is also equatorial of vertical direction, clear, or vertical dipole moment. So both have two cases we have to calculate. After that, we have to calculate net resultant electric field intensity. Clear? In along the axial line, the electric field intensity which is moving away from the point P, that is along OP direction, because already I have discussed about electric field intensity at a point due to an electric dipole at an axial line, which is along the direction of dipole moment. So it's moving along the direction of dipole moment. This is the direction of dipole moment, and this is the direction of electric field, moving away from the point P. Similarly, if you represent in vertical direction, the point P is situated at an equator line and having distance r from the center of the dipole. Here we know the electric field intensity, which is opposite to the direction of dipole moments. Here the dipole, whose direction of dipole moments represent p sin theta along minus q to plus q charge, but the electric field intensity at an equator line due to an electric dipole whose direction opposite to the dipole moment. Clear? Here we write. Now we have to calculate electric field intensity at any point P due to an electric dipole. Okay, that point P is situated at a distance r from the center of the dipole AB, that is OP equal to R. Here, so this is the distance between O to P is R. Clear? Here we write electric field intensity due to an electric dipole at an axial line is given by E vector mod axial equal to 1 by 4 pi epsilon 0 to P represent as a P cos theta by RQ, because here we write, so this is the axial line and this one is the dipole moment, horizontal dipole moment, which is represented by the resultant dipole. So here point P is here at a distance r from the center of the resultant dipole. Now I have to calculate electric field intensity at that point P, so that the direction of electric field intensity, which is along the direction of dipole moment and away from the P, so this is the direction of dipole moment. So that P vector can be represented as a P cos theta. We know the electric field intensity is given by 1 by 4 pi epsilon 0 P by RQ. So P can be represented P cos theta. So 1 by 4 pi epsilon 0 P cos theta by RQ. Equation number 1. Similarly, electric field intensity due to vertical dipole is given by, it means that is directly mentioned, is given by E vector mod equatorial or vertical trail is given by 1 by 4 pi epsilon 0. P can be represented as P sin theta by RQ. Why it becomes P sin theta? Because here in that case, so that point P behaves as the equatorial point of that dipole. So that dipole create a dipole moment that can be represented as a P sin theta. So we have to notify P can be represented as a P sin theta. Okay. So here we write E2 or E equatorial equal to 1 by 4 pi epsilon 0 P sin theta by RQ. Therefore, net electric field intensity at point P is given by E vector equal to, here in that case, here the direction of dipole moments of that vertical line which is along that way, but the electric field intensity of vertical direction or equatorial line is given by opposite to that of dipole moment. So this is the resultant electric field of Cairo of equatorial line, and this is the resultant electric field of axial line. So net electric field E is given by, according to parallelogram law of vector addition, E vector equal to, I'm लिखिପାରିବା E1 vector plus E2 vector, and their magnitude can be represented as E1 E vector mod equal to square root of E1 mod rho square plus E2 mod rho square. Clear? So here write E1 vector plus E2 vector. So in that case, in magnitude form, E vector mod equal to square root of E axial rho square mod rho square plus E equatorial mod square. So here we write 1 by 4 pi epsilon 0 2 p cos theta by rq square root rho whole square plus 1 by 4 pi epsilon 0 p cos sin theta by rq rho whole square. So here we write, if you taken common 1 by 4 pi epsilon 0, here p is also here, rq is here, so all are taken common, so p by rq is here, so square root of what, 4 cos square theta plus sin square theta is here. Okay, now it can be represented as 1 by 4 pi epsilon 0 p by rq, here 3 cos square theta plus cos square theta. 3 cos square theta means 4 cos square theta plus sin square theta. So that implies 1 by electric field intensity is represented as 1 by 4 pi epsilon 0 p by rq, here 3 cos square theta plus sin square theta equal to 1. So 3 cos square theta plus 1, square root of 3 cos square theta plus 1. So net electric field intensity whose magnitude is given by 1 by 4 pi epsilon 0 3 cos square p by rq 3 cos square theta plus 1 square root. Or another way, electric field intensity is given by 1 by 4 pi epsilon 0 p by rq square root of 3 cos square theta plus 1. Clear? Now you have to calculate direction. Here from above diagram, here that resultant electric field intensity create an angle alpha to the axial line. So that alpha can be represented as a direction of electric field intensity. So here we write the direction of electric field intensity is given by E is given by tan alpha equal to p by b. So because direction can represent alpha, so about in consideration, alpha means it is tan alpha and that side equal that side, so it can be represented by perpendicular by base. So we write tan alpha equal p by b, that is equal to p means a2 vector mode by a1 vector mode, that means 1 by 4 pi epsilon 0 p sin theta by rq divided by 1 by 4 pi epsilon 0 to p cos theta by rq. In place 1 by 4 pi epsilon 0, 1 by epsilon cancel out, pp here cancel out, rq cancel out, so tan alpha equal to half sin theta by cos theta, means tan alpha equal to half tan theta. So this is the direction of net electric field intensity at any point due to an electric dipole. Case 1, if theta equal to 0 degree, if theta equal to 0 degree, field intensity whose magnitude is equal to 1 by 4 pi epsilon 0 p by rq into square root of 3 cos square theta plus 1. Here theta equal 0 degree, so 1 by 4 pi epsilon 0 p by rq 3 cos square 0 means cos 0, since cos 0 equal to what, 1, so cos 0 equal 1, so 3 plus 1, so square root, so that implies 1 by 4 pi epsilon 0, that means square root of 4 is 2, so that means 2p by rq. Hence net electric field is given by 1 by 4 pi epsilon 0 to P by RQ. Hence, this is known as the net electric field intensity due to an electric dipole along axial line. Similarly, case 2 is here. Case 2. If theta equal to 90 degree, then E vector mod equal to 1 by 4 pi epsilon 0 P by RQ square root of 3 cos square theta plus 1 cos 90 degree is 0. That implies E vector mod equal to 1 by 4 pi epsilon 0 P by RQ 0 plus 1. That implies 1 by 4 pi epsilon 0 P by RQ. So E vector mod. So this is the resultant electric field of equator line. Hence, this is the electric field intensity of magnitude of electric field intensity of equator line. From any point we have to calculate both axial line as well as equator line. That means if in above diagram if theta is 0 degree, that implies theta is 0 degree, so that line which is moving in that direction along the resultant dipole, and alpha is also 0 degree. For the consideration, the point P which lies along the resultant dipole, so it generates a electric field intensity due to along axial line. If theta equal to 90 degree, then it represents as equator line. So alpha is also creates certain value. So the net electric field intensity due to equator line is given by 1 by 4 pi epsilon 0 P by RQ. For that, two electric field intensity of axial and equator line from above any point.